Okay, so today we're going to learn about transformations of linear functions. You're going to be moving the function around, up, down, side to side. Why is that important? You use this in geometry also. Transformations is representing how input and output change, and also how the graph changes. How is this used in the real world? Who here knows and remembers how old school cartoons were made? How did they make the cartoon look like he's running, like Super Mario running? Yes?
Oh, like really old cartoons?
Yeah.
So they used to sketch it on paper, then they take these plastic sheets and they have a background and they paint it and take a picture one by one.
Exactly. They have one slide by one slide by one slide. Old school also, they would draw pictures in a book and then flip it. When they flip it, what does it look like is happening? It's running and moving. It's not really moving, it's that you draw the picture in different positions. You do that in algebra. If everyone looks up there at that poster, the cupcakes are rotated around, right? The shield is rotated around, but it's also enlarged. That's called the dilation. You can slide, you can rotate, you can flip. So those movements are called transformations. Everyone say transformations. In geometry, you're going to transform or move figures. In algebra, we're transforming or moving the graph. Linear functions, quadratics, absolute value function. So today's essential question is, what is a vertical shift and what is a horizontal shift? So we're going to be moving the graph vertically and horizontally. Can everyone see the board well? Gracias. How is a vertical or horizontal shift represented in the equation of a linear function? So two types of shifts. We're going to do a vertical shift. A vertical shift shifts the graph up or down. A horizontal shift is a shift that is left or right. When you're shifting a graph up or down, which coordinate do you think is affected, X or Y, when you shift up and down?
Both Y.
Y. Which axis is vertical?
X.
No.
Y.
Vertical means up and down.
Oh.
So Y, the Y-axis is up and down. So when you shift something, when you're moving it on the graph up and down, you're changing the Y coordinate. So we're going to write that down. F of X plus K is when you shift it up. You're changing the input. So you're adding K to the input. K is any number. When you shift down, you're subtracting from the input. In both cases, did I say input? Sorry, output. In both cases, you're changing the output by either adding or subtracting from it. We can also shift the graph left and right. When we're shifting left and right, we're changing which coordinate? X, very good. So we're changing the input. So it would be F of X plus H for left, and I know it's opposite, but I will discover why later. And to the right, it's F of X minus H. In both cases, we're changing the input. Okay, so I want you to notice for input, think of input, you're putting the variable inside the parentheses. So here we're adding H, subtracting H from inside the parentheses. When you think of something moving to the left, look at the number line. When you move to the left, what kind of numbers do you see? Negative, right? You think of the left as subtraction. But with shifting functions, it's opposite. If you're subtracting, you're actually moving to the right, and adding is actually moving to the left. So it kind of does an opposite movement, and we'll explain why later on. Okay, so linear parent function, this is our parent function, formerly known as mother function, which I prefer calling it affectionately mother function. Okay, each function has an OG. Every other function spawns from that function. The original is x. Everything else comes from that function. So f of x equals x is our mother function. It's a linear function. You'll also see it as y equals x. That's another way of expressing it. This mother function has a slope of 1, because there's an invisible 1 in front of that x. 1 times x, basically. And the y-intercept is 0. This function starts at 0. It's like adding $1 to your bank account every week. That's your basic function. Add plus 1, plus 1, plus 1, plus 1, plus 1. You started at 0, and you added $1 every week. That would be considered your mother function. Okay, notice here it says y equals x. They're equal to each other. So if x equals -3, what does y equal? -3. They're equal. What's another name for x values? Domain. Very good. And what else is domain called? Input. What else is it called? Starts with an I. Independent variable. That's important. It's your independent variable. I put VAR. I'll zoom in. Try to. Independent variable, as in you can pick whatever number you want for the domain. I picked small numbers because our graph has small numbers. Okay, so I picked small numbers because our graph is small. I'm not going to pick 10 because 10 is not even on the graph. That's why, and you always want to pick some values that are negative, 0, and some positives, so you can get a good idea of what the graph looks like. Okay, what's another name for our y value? Range. Output. Dependent variable. Very good. I'm kind of just abbreviating it for dependent variable. So y depends on x. You can't just pick any value for y. Y is always going to depend on what x is, because there's a function rule. Here the rule is whatever your x is, multiply it by 1. That's why the values are equal. So for the mother function, x and y are equal, because we're just multiplying by 1. Then we graph it. When you graph, you start in the middle, and then you look at your x value. If it's negative, you go to the left. The y value, if it's negative, you go down. So we go to the left 3, down 3. Here's our -3, 3. -2, -2. To the left 2, down 2. -1, -1. 0, 0. 1, 1. Notice how the points are. We can continue this pattern. To get from one point to the other, how much are you rising? How much are you running? 1. That's your mother function. Up 1 over 1. Going through the origin. So we could put more dots simply because I don't have a ruler and I want my line to be straight. So up 1 to the right 1. Up 1 to the right 1. And we're putting in all of our ordered pairs. You connect it to form your straight line. So this is how your mother function looks. It's a slanted line that goes through 0, 0, the origin, and the slope is up 1 to the right 1. Now, this is your original function. Everything else is going to spawn from here. Let's talk about the features of this graph. The linear parent function is an increasing function. It increases by 1 for every x value, the y value goes up by 1. And it passes through the origin, 0, 0. In the table, the x and y values are equal. or in the front of your paper, where it says, what is a vertical or horizontal shift? How is a vertical or horizontal shift represented in the equation of a linear function? Our first vertical shift we're going to look at, as an example, is y equals f of x plus 2. Another and more common way that you will see this is as such. G of x equals f of x plus 2, or h of x, k of x. When you shift a mother function, you make another function, a new function. Why did that sound so weird? I don't know.
You said it with so much power.
All right.
Yo, you said it with pride.
Yes.
That power.
There you go. All right. So I guess you can call it a daughter function, or offspring function,
Baby function.
or son of a function, who is also a function. All right, I'm getting carried away. So, again, for our domain independent variable, we can pick any numbers we want. Let's stay with the same, -3, -2, -1, 0, 1. Now we have to apply the rule. A vertical shift, we're adding 2 to the output, so the output changes with vertical shifts. So we're going to look at the old output and add 2 to it. The old output was -3, but now we're going to add 2. What is the new output?
-5. What?
-1.
Let me pause this. Okay, so our new output's -1. -2, it's okay. A lot of students sometimes make mistakes with positive and negatives. If you're not sure, always use a calculator. You don't want to get it wrong just because of that. Because if your output is wrong, the whole graph is going to be wrong. -2, we go ahead and add 2 to our output. What is our new output? 0. Our old output was -1. We added 2. What is our new output? 1. Our old output was 0. We added 2. What is our new output? Our old output was 1. We add 2. Tree. So now we have new ordered pairs. -3, -1, -2, -0, -1, 1, 0, 2, and 1, tree. And we're going to plot that on the graph to see how the graph changes. -3, -1, we go to the left 3, down 1. -2, 0 is right on the x-axis. -1, 1, 0, 2, and 1, 3. If for any reason you forgot how to plot points, make sure you go on Khan Academy and practice it. How to plot points, or Google it. It's important for you to self-advocate. Everyone say self-advocate. Self-advocate. Advocate means to help. So self-advocate, what does that mean? Help yourself. So if you know there's something you're struggling with, don't wait for the teacher to help you. Go and find the help, right? Teach yourself. Look up a video. Ask somebody. Also, you get free tutoring, Varsity Tutors. Make sure that you use that resource. So let's zoom in. What do you notice happened between the old point and the new one? It went up by 2. Does it make sense that it went up by 2? Yes, exactly. A vertical shift makes the graph go up by 2 units in every single spot. Let's connect those. I'm going to add some more points, and let's connect that. And we have our shifted function. If you have colored pens, this is where you would use them, right? Because if you use pencil for both, you can label it. This one here is f of x, and the blue one is g of x. But if you're using colored pens, it'll be good for your notes. That way you know what you're doing. You can differentiate. Now let's analyze this graph and see what changed, what stayed the same. The key features. Everyone say key features. The key features is the slope. We want to look at how did the slope change. and the y-intercept. Okay, slope is rise over run. What is the rise over run in the old graph? 1. Because it goes up 1 to the right 1. Right? It does like a little staircase where you're going up 1 step to the right 1 step. Let's look at the new blue graph. Did the slope change? Did it produce a higher, is it still, what is the rise? Ask that.
The rise of the new one and the old one.
The new one, what's the rise? No, from here to here. Right here. It's 1 box.
Yeah, one.
That's 1. And then to the right? How many units did it go to the right?
1 again.
1. So did the slope change?
No.
No, it was both of them, the slope is the same. Okay, did the y-intercept change? This is the y-intercept where the graph crosses the y-axis. Here it crosses at 0, 0. Over here, where does it cross? What point is this?
What?
What?
That one?
Yeah.
That's 2.
No.
0, 2.
0, 2. So the y-intercept changed. It changed from 0, 0. When we moved it up, now it crosses at 2. So the y-intercept changed from 0, 0 to 0, 2. The slope stayed the same. What kind of lines are these? How do they relate to each other? They don't touch and they're going in the same direction. Parallel. We produced parallel lines when we shifted it. Write that down, that's important. When you shift a linear function, you're producing parallel lines. So all the lines will have the same slope, but different y-intercepts. All right, the graph of y equals f of x plus 2 shifts the mother function up 2 units. In the table, the y values of the parent function increase by 2. How will the graph of y equals y equals f of x minus 5 differ from the linear parent function? So if this pattern continues, who can tell me what this will produce? What will subtracting 5 do to the function?
Make it go down.
Down by how many?
5.
Very good. Shift down 5 units. So before we move on to the next example, I'm going to test the class really quick. I'm going to write down function notation, and you're going to tell me if it moved up or down. Class, f of x plus 1. By how many units?
1.
So you would say up by 1 unit.
Up by 3.
Up by 3 units.
What changed, the input or the output? Output. If you see the plus outside of the parentheses, you're changing the output. Class?
Down by 7 units.
Down 7 units. Very good. And the y coordinate, you also subtracted 7. Alrighty then. Let's go to the horizontal shift. Everyone say horizontal shift. The horizontal shift changes the input. Inputs change input. Notice inside the parentheses now. So this would be an example like h of x equals f of x plus 2. That's another way to write it. Okay, the reason why addition actually moves the graph to the left is only because it looks like that happens. It doesn't actually happen that way. So for the purposes of you understanding, we're going to do something with the input. You'll learn more of why this happens as we get into quadratic and absolute value functions. So remember our old input, sorry. Our old input was -3, -2, -1, 0, 1. Now we're going to subtract 2 from each input because we do the opposite. Even though it says +2, we're going to do the opposite and subtract 2. What is your new input? -5.
Well, yeah, -5.
-4, what else?
-3 and just 2.
No.
-2.
-2.
And then -1.
Very good. And our output is going to stay the same as it was before because the output didn't change, only the input. And we plot the points. -5, -3. So it's right here. -4, -2. -3, -1. -2, 0, -1, 1. If we zoom in, what do you notice is happening to the coordinates? In what direction? To the left. To the left, to the left. And this is our h of x and our original f of x. F of x got shifted to the left 2 units. Even though it says x plus 2, it's actually to the left. Okay, the graph of f of x plus 2 shifts the parent function left 2 units. In the table, the x values of the parent function decrease by 2. Who can tell me what f of x minus 5 inside the parentheses will do to the function?
Down.
No, it's not moving up or down, it's horizontal movements.
Oh, maybe
It'll
go
go
It's either left or right.
left.
It's opposite of what it looks like.
right.
Yes. Very good. This will move right 5 units. Opposite of what you think. Okay, let's do some for testing the class. If we have f of x plus 1, what kind of movement is that, class? Left 1. It's opposite. If it's plus, it's left. If it's minus, it's right. F of x plus 10.
Left 10.
Very good. F of x minus 3.
All right.
Very good. Now, let's mix it up. F of x plus 7 minus 10. There's 2 things that happen to the function.
Wait.
It'll go
It'll go
right.
No.
No, go left and then.
Left. No, it does 2 things.
So we go
Left 7 and then down 10.
Oh, down 10. Oh, that's it. Oh.
Let me give you an example. You got your OG parent function. Then you have to go to the left 7 and down 10. So now your new graph is going to be over here. And it has to look parallel.
So positive is.
Because we didn't change this up.
Oh, so.
So if the green line has an arrow, so it actually keeps going. So now you have a parallel line. So if this was your original function, if you're moving to the left 7 and down 10, your new function is going to be somewhere down here. So you're moving to the left 7, down 10. All right, let's mix it up. F of x minus 3 minus 13.
It go, what is it called? It go right, it go right 3 and down 13. Down 13.
Very good. All right, so to end, In your own words, answer the essential questions. The essential question was in the previous. Take a moment to answer that in your own palabras.